So now that we've spent a lot of time talking about quadrantal angles, today we're going to figure out how to find angles of special triangles. This is section 5.3, and it's called Trigonometric Function Values and Angle Measures. So we have triangles that we learned about in geometry. You need to remember these lengths. So for a 45, 45, 90 triangle, the side opposite those angles are 1, 1, and root 2. Root 2 is about 1.4, so it's bigger than 1. And anytime we have a special triangle, the smallest side is always 1. So try to commit those to memory. Another triangle that you learned about in geometry is a 30, 60, 90 triangle. Like we said, the smallest side is opposite the smallest angle. So always opposite the 30 is always 1. Opposite the 60 is always the square root of 3. And the hypotenuse for this triangle is 2. Now the square root of 3 as a decimal is it's about like 1.7 or so. So 1.7 is smaller than 2, and it's important that you remember the lengths of each of these sides opposite their angles. Those are special triangle angles. Now don't forget, if our angle lands on an axis, it's called a quadrantal angle. And we use our points 1, 0, 0, 1, negative 1, 0, and 0, negative 1 to figure out their values. Sine, we talked about, was the y value of that point. Cosine is the x value. And tangent is the y value divided by the x value. We use this when we're talking about quadrantal angles. All right, so now let's get into some specifics about our special triangles. In order to figure out these problems, we have to talk about what's called a reference angle. We talked a little bit about this in previous sections. We'll talk about them in depth now. A reference angle has three things. One is it always connects to the x-axis. Second component is that it's always positive. And the third component is the reference angle is always less than 90 degrees. So for example, a reference angle would look like this in quadrant 1, or like this in quadrant 2, or like this in quadrant 3, or like this in quadrant 4. All of these angles are less than 90 degrees. You would make them positive, and all of those angles are less than 90 degrees. I'm not even going to mention the other axis. We only focus on the x-axis. So your angle is going to look something like those four. If it looks different, so let me show you, maybe it's better if I show you what some wrong problems look like. It's wrong to draw an angle like this. Please don't ever do that. That's really, really bad. Please don't ever do this. Yeah, that's using another axis. That's totally bad. Okay, so please don't do either of those two options. It needs to look like one of the blue options. So let's do an example here. So let's find the reference angles. and we'll use 30 degrees. I have 6 here, so we'll go through this. 30 degrees, if we draw it, it's like right here. Remember, all of our angles are in standard position. It's less than 90 degrees. So what would the reference angle be? Well, that looks like one of the options. Reference angle would connect our terminal side with the x-axis. So our reference angle would be 30 degrees. What about 120 degrees? Well, 120 degrees is past 90, but not quite at 180. So that would be like right here. It's 120 degrees. Connect to the x-axis. Well, 120 is too big. It has to connect to the x-axis. So if we go 60 more degrees, that would get us to the x-axis. It's positive and it's less than 90. 60 degrees, whatever it takes to get to the x-axis, is your reference angle. So theta would equal 60 degrees for this example. What about 240 degrees? Well, 240 is past 90, past 180, not quite at 270 though. So this is 240 degrees. We have to get to the x-axis. So you don't want to go this way, because to go from 240 to 360, that's 120 degrees, and that's too much. It has to be less than 90. So what's the fastest way back to the x-axis? Well, we pass the x-axis 180 degrees by 60 degrees. That is our reference angle. Just think about what's the fastest way to get to the x-axis. 60 degrees would be your answer. How about, let's do some negative angles. What about if we had negative 190 degrees? Well, negative angles, we go this direction. This would be negative 90, this would be negative 180, and we're going to go a little bit more to get to negative 190 degrees. What's the fastest way to get to the x-axis? We went negative 190. 10 degrees would get us to the x-axis. Now you don't want to say negative. Reference angles are always positive. So just 10 degrees would be our answer here. What about negative 290? Well, negative 90, negative 180, negative 270, negative 290 is maybe over here. It's past negative 270, but not quite at negative 360. What's the fastest way to get to the x-axis? Well, we don't want to go to 270 because that's a totally wrong axis. Let's go this way to get to the x-axis. That's 360. We went 290. How much more to get to 360? 70 degrees. And then our last example. What about negative 95 degrees? Well, negative 90 puts us here, so negative 95 goes a little bit more. That's negative 95. Don't go to the other axis. We always go to the closest way to get to the x-axis. So negative 95 is bigger than 90, so we can't use that. But how much more is it to go to negative 180? So what's the difference between 180 and 95? That's 85 degrees. That would be our reference angle. Now, I'd rather you figure these problems out using this, but if you would like a formula, it can get a little bit complicated for reference angles. Generally, if we're in the first quadrant, we just figure out like whatever the angle is in the first quadrant. It's in quadrant 1. In our second quadrant, we could do 180 minus our angle. In the third quadrant, we could do our angle minus 180. And in the fourth quadrant, we could do 360 degrees minus our angle. Now this works if your angle is less than 360 and if it's positive. I think it's beneficial to figure out the reference angle the way that we did for these 6 examples. Okay, so now this is the most important thing in trigonometry, this example right here. Find the exact values of the 6 trigonometric functions. Okay, so let's figure this out. First one is 30 degrees. Let's draw it. 30 degrees maybe over here. That's a special triangle. So we have a 30, 60, 90. Let's label our sides. Anytime opposite the 30 is 1, the 60 is root 3, our hypotenuse is 2. This is our reference angle, which all of our angles are going to be based on. So to figure out the sine of 30, we're going to be using the reference angle 30 degrees. I'm used to writing theta, but the reference angle we are using is 30 degrees. No matter what angle you're given, you always use the reference angle to figure these out. Okay, so the opposite side of 30 is 1 over 2. Cosecant would be 2 over 1. The adjacent side is root 3, so root 3 over 2. Reciprocal is 2 over root 3, which will rationalize. Tangent would be opposite over adjacent. The reciprocal is root 3 over 1. And we just have to rationalize 1 over root 3. So our answer would be root 3 over 3. Those are the 6 values here. We're going to do a few more examples because it's really important that we get this. Now there is a supplemental worksheet that you could find by clicking the appropriate link. This is really, really important. So let's do 210 now. So we're going to pass 90, we're going to pass 180, 210 puts us somewhere over here. What would be the reference angle? Well, the fastest way back to the x-axis from 210 is 30 degrees. So we have another 30, 60, 90. 1 is opposite the 30, 2 is the hypotenuse, root 3 is the other side. But remember, anytime we're drawing triangles and we go down or left, that side has to be negative. So we're going to have sine. So the sine of 210, the cosine of 210, I'll just set it up here. Now the sine, here's your reference angle. Sine would be the opposite over the hypotenuse. Negative 1/2, the reciprocal is negative 2 over 1. Cosine is the adjacent over the hypotenuse. The reciprocal would be 2 over negative root 3. It doesn't matter where you put the negative. Let's rationalize this. And we get negative 2 root 3 over 3. And tangent would be the opposite over the adjacent. Reciprocal would be root 3 over 1. So let's multiply by root 3 over itself. And we just get root 3 over 3. Let's try 60 degrees. Or let's make it negative 60 degrees. Make it a little bit more interesting. Negative 60 degrees will put us like over here. Now, we don't want to write negative 60. Our reference angle is always positive, so we'll put 60 here. which means we have another 30, 60, 90 triangle. Opposite the 30 is 1, the hypotenuse is 2, the opposite side to the 60 is root 3, but because it's going down, we'll make that negative. Anytime you go left or down, that side is negative. I mean, you could check these answers in your calculator, but you're really expected to be able to do this by hand. Looking at our triangle, we do have an opposite side, we have an adjacent side. So the sine would be the opposite over the hypotenuse, and the reciprocal would be negative 2 over root 3. Rationalizing would be negative 2 root 3 over 3. Cosine would be the adjacent over the hypotenuse. Reciprocal would be 2 over 1. Tangent would be the opposite over the adjacent. Reciprocal would be 1 over negative root 3, which we could rationalize and get negative root 3 over 3, while tangent is just negative root 3. Let's go to 495. Let's do a bigger one. Now 495 degrees. Let's see. You have to figure out the reference angle. So 90, 180, 270, 360, 450, and then 495 would be over here. That's 495. But we want to get to the x-axis. So the x-axis would be 540. So what would the reference angle be? Well, we'd have to go another 45 degrees to get there. So our reference angle is 45, which means this other angle would be 45. And remember, the sides opposite 45 are 1, 1, and root 2. So anytime you go left or down, those sides are negative. And this is our reference angle. So this would be the adjacent side. This would be the opposite side. And let's figure it out. So the sine would be the opposite over the hypotenuse. Cosecant would be the reciprocal. So let's rationalize sine. And this is going to come up over and over again. So just recognize that 1 over root 2 rationalized is just root 2 over 2. Also, 1 over root 3, you should recognize, is root 3 over 3. We'll get more experience with that, though. Cosine would be the adjacent side over the hypotenuse. So rationalized would be negative root 2 over 2. And secant, we could just flip 1 over root 2 and get root 2 over negative 1, which is just negative root 2. Tangent would be the opposite over adjacent. Flipped, of course, would still be negative 1 over 1, which is just negative 1. Okay, I want to do 4 more just to make sure that we get this. And I would encourage you to look at the supplemental material, especially the one with the school bus on it. That's a really good worksheet. Negative 225 degrees. Let's figure this out. So it's negative. So this would be negative 90, negative 180. Negative 225 would be somewhere over here. What's the fastest way back to the x-axis? Well, that's this way. How much did we pass negative 180 by? 45 degrees. We have another 45, 45, 90 triangle. Opposite the 45s are 1. The hypotenuse is root 2. Anytime you go left or down, it's negative. So the sine of negative 225, cosine, tangent. So the sine would be the opposite side over the hypotenuse. Remember, our reference is always squeezed in between the x-axis. So sine would be 1 over root 2, which the reciprocal would be root 2 over 1. Anytime you go left or down, that side is negative. The common mistake is sometimes people forget to do that. Cosine would be the adjacent over hypotenuse. Reciprocal would be root 2 over negative 1, which is negative root 2. Rationalized would be negative root 2 over 2. And then the tangent would be 1 over negative 1. And cotangent would be negative 1 over 1. Okay, let's try 180 now. Now 180 degrees is a little bit different because that puts us right on the axis. This is called a quadrantal angle. When you have a quadrantal angle, remember that y is the sine value, x is the cosine value, and y over x is your tangent value. This point right here would be negative 1, 0. So we don't have to make special triangles. It's either going to be a special triangle or a quadrantal angle. Quadrantals are generally easier. So sine is the y value. The reciprocal of 0, well, we could even put 0 over 1 if you want. The reciprocal would be 1 over 0, which is undefined. Make sure you say undefined. 1 over 0 is nothing else. The answer is undefined if you're dividing by 0. Cosine is the x value. You could put it over 1 if you want. So when you take the reciprocal, you get negative 1. And the tangent would be the y value over the x value. The reciprocal would be negative 1 over 0, which of course is undefined. I have a couple more. How about 270 degrees? Let's draw this out. 270 puts us right here. Well, it's another quadrantal angle. That point would be 0, negative 1. So let's find our 6 trig values. Okay, sine is the y value, so the y value of this point is negative 1. The reciprocal, of course, would be 1 over negative 1, which is still negative 1. The cosine would be the x value, which is 0. You can make it 0 over 1 if you want, so when you go to take the reciprocal, it's 1 over 0 or undefined. And then the tangent is y over x, so negative 1 over 0. The reciprocal would be 0 over negative 1. Cotangent would be 0, but anytime you have 0 on the bottom, in the denominator, we talked about that being undefined. We'll do one more. How about negative 630 degrees? So negative means we're going to go this way. Negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, negative 630 puts us right here. So sometimes you have to keep going up by 90 until you get there, but it's not a big deal. That point would be 0, 1. Here's our x value, here's our y value. So let's find our 6 trig values of negative 630. So sine would be the y value, which is 1. Cosecant, we're going to take the reciprocal. So if you want, you can make this into a fraction. If that helps you find the reciprocal, 1 over 1 would still be 1. Cosine is the x value, so that's 0. That's the answer. But to get secant, you can make a reciprocal of 1 over 0, which we know is undefined. And then for tangent, tangent is the y value divided by the x value, which is undefined here. And for cotangent, if the reciprocal would be 0 over 1, which is just 0. It's a really important lesson. I hope that makes sense. Please make sure you take a look at the supplemental material. Stay tuned for our next lesson.